Everyone, this is the second grade enhanced math week 3 solution video. Problem 1, compute the following. 45 minus 12, so that's the first equation. We can write this out in ladder method, 45 minus 12. We start for the right side always, so 5 minus 2 is 3, and 4 minus 1 is 3 as well. So therefore, this gives us 33. Next up, 76 minus 25. So 76 minus 25, again, we start on the right-hand side. So 6 minus 5 is 1, and 7 minus 2 is 5. So that gives us 51. And then next equation, 42 minus 19. And this time we see that 2 is smaller than 9, so this can't possibly work. So therefore, we need to borrow a 10 from the 4. So we cross 4 out, this becomes 3, and we carry over the 1 to the 2, and the 2 becomes 12. So we can do 12 minus 9 equals to 3. Then we carry the 1 over to the left-hand side. And this becomes 3 minus 1 equals to 2. So this is 23. And then the next question, 50 minus 25. And again, 0 is smaller than 5, so this can't possibly work. So we have to carry a 1 from the 5 on the left-hand side. So 5 becomes 4, and we carry the 1 over here, and this becomes 10 minus 5, and this gives us 5. And then for the left-hand side, 4 minus 2 is 2, so that's 25. Next, 94 minus 37. So again, 4 is smaller than 7, so we borrow a 1. 9 becomes 8. This becomes 14 minus 7. 14 minus 7 is 7. 8 minus 3, 5. 57 is our answer. And finally, 81 minus 28. So again, 1 is smaller than 8. Borrow a 1 from the 8 on the left-hand side. The 8 on the left-hand side becomes 7. The right-hand side becomes 11 minus 8 equals to 3. Then we write 3 at the bottom. 7 minus 2 equals to 5. This becomes 53. Very straightforward problems. Let's move on to problem 2. For problem 2, Leo is 13 years old and his dad is 40 years old. How many years older will be Leo's dad than Leo 5 years later? So the age gap never changes. For example, if someone is 13, for example, Leo is 13 right now and his dad is 40 years old right now. In 5 years, just because 5 years has increased, they each add 5 years. So the age gap never changes. So let's just follow the question. If Leo's dad than Leo 5 years later, then Leo just becomes 13 plus 5, which is 18. And the dad is 40 plus 5, which is 45. And of course, 45 minus 18. Let's draw this out. We borrow a 1 from the 4 because 5 is smaller than 8. So 4 becomes 3. And the right-hand side becomes 15 minus 8, which is 7. And 3 minus 1 is 2. So the age gap is 27. And that remains the same if we go back 5 years, because 40 minus 13 is still going to be 27. So the age gap never differs. So the answer is 27. Problem 3. John finished reading an 86-page book in 3 days. On the first day, he reads 26 pages. If he reads the same number of pages on the second and third days, how many pages did John read on the second day? So in total, there are 86 pages. And then on the first day, he reads 26 pages. So we just subtract 86 from 26. That's very straightforward. That gives us 60 pages left. And then on the second day, if he reads the same number of pages on the second and third days, how many pages does John read on the second day? So in total, if there are 60 pages, then 60, if you split it into 2 with the same number on each side, this just gives us 30 pages plus 30 pages. And as you can see, these two 30s are the same number, and they give us 60 in total. So therefore, how many pages did John read on the second day? That's just 30. Moving on to problem 4. And this is you have to plug in the numbers in order to solve it. So for the first one, it's 30 something minus 13 equals to something 5. And we know that we can straight away just find out that this is just 8, because 8 minus 3 is equal to 5. And then without carrying over, we know that 3 minus 1 equals to 2. So therefore, that gives us 25. 38 minus 13 equals to 25. Moving on, this time it's something 2 minus 46 equals to 30 something. And obviously 2 is smaller than 6, so we need to carry over. So it borrows a 1 from here, and this just becomes 12 minus 6 equals to 6. So we plug in 6 over here. And because we borrowed a 1, so this number needs to be plus 1. So originally, this has to be 8, and then we subtract 1, which gives us 7, and then 7 minus 4 equals to 3. So it's 82 minus 46 equals to 36. And then for the third one, it's 90-something minus something 6 equals to 35. And again, we need to carry over this time again. We get something minus 6 equals to 5, and that's just 11. So we borrow a 1 from 9, and this 9 becomes 8. And 8 minus something equals to 3. That just gives us 5, because 8 minus 5 equals to 3. So the third equation is 81 minus 56 equals to 33. And the final equation is something 0 minus 40 equals to the number of 18. And again, we can solve this because nothing is smaller than 0, and this digit is probably bigger than 0, since or else how would you get 8? So therefore, we borrow a 1 from the left-hand side, and this just becomes 10. 10 minus something equals to 8, that's just 2. So we write 2 here. And then since we borrowed a 1 from this side, we need to increase it by 1. And this just gives us 6, because originally 5 minus 4 would be equal to 1. But since we borrowed a 1, we need to let it be 6 so that the 1 can be taken over. So therefore, 60 minus 42 is 18. And that's problem 4. Problem 5. A, B, and C are 3 different numbers. If A, B, B minus C equals to C, A, then what are these 3 numbers? These B, B would have to be the same number. So you can just guess and check for these 3 numbers. Once you guess and check, we do know that B and B must be the same number, and we can just do B as 0, for example. And if this is 0, then we have to do a number that fits into this equation. So if A was 2, then that would be too large, since 200 minus 99 at the most, since C is only 1 digit, so at most that would just be 99, for example, then that would be too small. So therefore A has to be 1. And then this would be 100. And 100 minus a single digit, see, let's do 9, for example. And if 100 minus 9, that gives us 91. And let's see if it matches. And yes, it does match. C is 9, A is 1, and B equals to 0. So for this problem, you can just play around with the numbers while knowing that B has to be the same and A can only be 1, since if A was 2, that'd be too large. Since C is just 1 digit, then C, A at the bottom, this is only 2 digits. So if 200 minus at most, if C could be 9, that would still leave you with 191, and that's not possible since 191 is 3 digits and CA is 2. So therefore, we have these answers. Moving on to problem 6. Lily and her friend Jessica went to a bookstore to buy books. Lily paid $36 for 3 books. Jessica bought 6 books by paying $50 in cash and paying remaining by a credit card. If the price for each book is the same, how much was charged Jessica's credit card? So we know that each book is the same, so Lily equals to pay $36 for 3 books. And if we know that the books are the same price, then we could just figure out that she paid $12 for each book, since 12 plus 12 plus 12 is 36, and she purchased 3 books. So each of these books is $12. So we know that each book is $12. So let's write that out. And then it gives us that Jessica bought 6 books by paying $50. For example, so if we know that 12, she bought 6 books and each book is 12, then we can just write it out as 12 plus 12 plus 12 plus 12 plus 12 plus 12. And since we know that 3 12s is 36 already by looking from the top, then we can just divide these into 2 36s. So 36 plus 36, that just gives us 72. So she paid $72 in total. But she says that she paid $50 in cash on top. So let me highlight this. It says she paid $50 in cash and paid remaining by the credit card. So all we have to do is subtract 72 by 50. So 2 minus 0 is 2, and 7 minus 5 is 2. So she has $22 left that she has to pay, and she paid that remaining by a credit card. So she paid $22 with her credit card. Problem 7. Laura got $100 from her mom to a shopping center with friends. She bought a $35 backpack. Then she spent $16 on lunch, $20 on dinner, and $12 on riding a Ferris wheel. How much money had Laura left? For this problem, she starts off with $100, and then the first thing she buys is a backpack. So we subtract 35 since a backpack is $35. And since we can't borrow a 1 from the first 0, then we have to borrow it from the left-hand side 1, and this one just becomes 0, and we can erase it. And then since we borrowed it, this the right-hand side becomes 10 minus 5 equals to 5, and then the right-hand side, since this cannot be borrowed more, this just becomes 9. Then 9 minus 3 is 6, and she has $65 left once she purchases the backpack. And 65 minus 16, since that's how much she spent on lunch, we can borrow a 1 from the left-hand side, 6, and the right-hand side becomes 15 minus 6. This just gives us 9, and 5 minus 1 equals to 4. So she has $49 left when she spends it on lunch. And then if she has $49 left, she also spent $20 on dinner, and we start from the right side, so 9 minus 0 is 9, 4 minus 2 is 29. And then finally, $29 minus $12 since she rode the Ferris wheel, 9 minus 2, 7, 2 minus 1, 17. So after her shopping spree, she still has $17 left to give back to her mom. Problem 8. While driving from the city to the lake, Karen passes the road signs shown in the diagram. City to the left is 50 kilometers, lake is the number of 80 kilometers. So about an hour later, she notices a sign just indicating that she has 5 kilometers to go to the lake. How far has she traveled from the city? So let's draw this thing out. So basically, this is her entire route, city, lake. And let's just assume that she meets the post in here. So we draw this out. So city, 50 kilometers, lake, 80 kilometers. And we know, let me draw this in green. We know that when she meets the post, she is 50 kilometers from the city and 80 kilometers from the lake. And then she drives for some more, and then she's just 5 kilometers from the lake, so we can draw that. She's about here, so this is just 5 kilometers from the lake. So assuming that she drove from the post until 5 kilometers from the lake, we can just subtract the 80 kilometers that she had in the first place to the 5 kilometers that she has left, and that means that she traveled 75 kilometers since leaving from the post. And then if she has traveled 75 kilometers, we just add the 75 kilometers to the 50 kilometers that she was starting from the city in the first place. So 75 plus 50, 5 plus 0 is 5, 7 plus 5 is 12. She has traveled 125 kilometers from the city. And that's all.